Okay, we're looking at number 2.6, and what we're supposed to be doing is we have this 300-pound force, and you want to resolve it into components along the A prime axis and the B prime axis, and we're supposed to calculate alpha if we know that the portion along the B prime axis is 120 pounds. And then we're supposed to turn around and figure out how much is along is the A prime axis. So what are we talking about? We're saying that we know that 120 pounds is in this direction, some unknown amount is in that direction, and what is alpha? Okay, so let's look at this triangle a little more carefully. I'm going to come over here. Okay, so I have this 60 degree, and I have 120 in that direction. And I am going to put it a little more extreme because I know the answer. This is what we're looking for, alpha, and I know that this is 300. And so I'm trying to figure out what, oh, that was pretty bad. Trying to figure out that part too. So the question is, what is this angle to make this work? Well, let's do a little bit of trig. If you have this and this are straight lines and you have this going in between it, you know that this is 60 degrees. And that's also true for this and this with this one. So this is alpha. So we're going to use the lovely law of sines, which basically says sine of A over A equals sine of B over B equals sine of C over C. So we know this one and this one, so we're going to say sine of alpha over 120 equals sine of 60 over 300. So therefore, sine of alpha is equal to 120 over 300 times sine of 60. My pen's being weird, sorry about that. So therefore, alpha is equal to 20.27. 20.27 degrees. Okay, so that's part A. So this is about 20 degrees. Now part B, we're supposed to figure out what is the magnitude of this one right here. So we can use the law of sines again. We'd have to know what this angle is here. So the way I'm going to do this is I can come up here, draw a straight line, and I know if this is 60, therefore this is 30. If this is alpha, this is 90 minus alpha. So therefore, I don't know, theta, we'll call it theta, is equal to 90 minus alpha plus 30. So that works out to be what, 99 point something, 99 like 0.97 I think is what it is. And then we're just going to do the law of sines and cosines again, except for we're going to do it off of this one. So we're going to say sine of 99.97 over x. So the angle, this angle over this number is equal to sine of this one, and we know both of these, so it doesn't much matter which one. We're going to say sine of 60 over 300. So since we're looking for x, therefore x is equal to sine of 99.97 over sine of 60 times 300. So x ends up being worth about 341. And there you go. That is the final answer. This is one of those problems where you kind of have to do it with the law of sines and cosines. It's just kind of meant for that. Again, I personally don't find the law of cosines and the law of sines. I don't use it all that often. It turns out this part, this second part here, you could do with the law of cosines, right? A squared equals, a little a squared equals b squared plus c squared minus 2bc cosine a. But, so you know b, so it's going to be a squared is equal to 300 squared plus c squared, which is 120 squared minus 2 times 300 times 120 times cosine of the angle, which is this angle, which we had to figure out right here, which is back to there, 99.97. At that point, to me, I would say it's just easier. Since you have to calculate that angle either way, it's easier to come up with this, but you still end up with A equals 341. Okay, there you go.